Welcome to section 5.5. Here in this section, we're going to remind you about the properties of logs, and all the problems are really geared to us utilizing those properties of logs and coming up with answers. And so, as I go look at the properties of logs with you again, I want to remind you that if you had log base b of m times n, that this is the log base b of m plus the log base b of n, and we use them interchangeably both ways. Sometimes we like to, in calculus you'll find that you're using logs to do this type of big split up, to going from the left hand side to the right hand side. In other situations we're combining two logs in order to solve something, and so you'll find that you'll use them both ways, and they'll have us practice both ways. And essentially these are coming from the exponent laws, right? They're proved in the book, but they're easily proved. But if you divide two things, then you subtract their exponents. Remember, these logs are just exponents. And so basically you're saying log of a product is the sum of the exponents, right? And that the exponent here is the subtraction because of the division. And so we even have log base b of m raised to the r power as r times log base b of m. Those are the three main properties of logs that are used a lot in order to rewrite things so that they're more easily handled in the situation. And so the homework's geared to give us practice with these and then utilize some other principles that are involved here. So let's take a look at something like number 1. It will say simplify using properties of logs. So they want us to use a property of logs first and then simplify. Some of these can be done, let me not call that 1, let me come in here and call that A. Some of these can be done, even just figuring them out individually, including this first one. So they have log base 5 of 25 minus log base 5 of 5. What they'd like for us to do first is write this as a single log. So this is log base 5 of 25 divided by 5. Simplify that. That's log base 5 of 5. And what power do you need to raise 5 to in order to get 5? Obviously that's 1. And you're done with that first problem. B. Here it looks a little bit strange, but they're going to try to draw out several principles at the same time. So let's focus on that exponent. They want us to use the property of logs to bring those together. Well, that's a subtraction again, so that's log base 3 of 7/8. Now, what is log base 3 of 7/8? It is the power to raise 3 to in order to get 7/8. So if you actually took that power and put it on a 3, you should get 7/8 out. And so it's one of those nice problems where you're just utilizing the inverse. So remember, log base 3 of 7/8 is the power to put on 3 to get 7/8. So if you actually put it on 3 like we have, here we're putting it on a 3, we get the 7/8 out. And so they'll have nice problems like that that are reinforcements of those. They'll have problems like this, where number 2, they want us to rewrite as a sum or difference of logs where powers are expressed as products. And this is probably the majority of the homework right here, this splitting up stuff, because there's a reason for that. It's what we do most in calculus. So ln of x minus 5 all over e to the 2x. And then I'm going to put simplify as much as possible. Okay, I'm just going to put that in there because we need to simplify this. So don't overwhelm yourself. Look at the main thing that's going on, which is the fraction bar. So this is the ln of the top thing minus the ln of the bottom thing. Sorry, e to the 2x. Now, there's no property that tells us of log of a difference. I see people do weird stuff with this, usually in an intermediate algebra class when they first learned it. you're stuck with that. There's no property of logs that deals with log of a subtraction or an addition. It's an addition of logs, a subtraction of logs, but not log of a subtraction. So this part is completely simplified, this first piece. So that's going along for the ride. Now, they do not want me to have powers involved. They want me to express powers as products. So what does that mean? It means the 2x floats down and we get ln of e. Now let's simplify. You know what the ln of e is. What power do I raise e to in order to get it back? 1. So this right here is 1. So the answer that they're going to give you credit for looks like that. Simplified as much as possible. B. And I just chose a few here. Same directions. ln of 7x times the square root of 1 plus 8x all over x minus 2 to the 15th power. So what is that? Well, that's the ln of 7x times the square root of 1 plus 8x minus ln times, or not, ln of x minus 2 to the 15th power. Now, you could think, well, how far do I need to go? In calculus, you want to go as far as you can. So they don't want anything multiplied together. They want they don't want anything divided. They don't want any powers. So we got to split this first thing. This is ln of 7x plus the ln of the square root of 1 plus 8x minus, and then here they're not going to want the power. So I'm going to bring the 15 out front. And then we're going to take a look at it. How about the ln of 7x? Is that a product? You bet it is. So they're going to want this as the ln of 7 plus the ln of x plus the ln of the square root of 1 plus 8x minus 15 ln x minus 2. Now that looks better, right, as we look at that guy. It's all split up, but there's a reason why we're not going to get full credit for that answer. Or that they won't even accept the answer, and that's because I haven't expressed all powers as products. Do you see the power that needs to be adjusted? Okay, hopefully you see it. It is right here, that square root guy. We can't leave that on there. We have to bring out that power. Hopefully it's ingrained in you already, but if not, it certainly will be. This is better. You absolutely want to get that 1/2 power down. Now, not just because they told you to. There will be a time that you do not want to have that 1/2 power on there, because it's much better to deal with it as a product than it is as a power when you're doing integration or differentiation, which is in your calculus class. So you can think, well, that's dumb. I should be able to stop at any point here. You wouldn't have stopped there. They need to give you practice breaking it down to its bare bones minimum. There are times in calculus where we put in, let's see what number I'm up to here, where we put in, we see some things split apart, we need to bring them together. So this one's going to say rewrite as a single log. And you're just going to be patient there. You're going to say, okay, here's the problem. This is ln of x over x minus 4 plus ln of x plus 4 over x minus ln of x squared minus 16. And again, we're going to simplify in the end. So we know what to do. Let's just take them one log at a time. Let's put these two logs together. This is ln of x over x minus 4 times x plus 4 over x. And then this one's coming along for the ride. I'm going to bring it down so we don't forget about them. I would simplify as much as possible. What can go away? I'll cross them out in red. These x's can go away. And so what do I have? I'm just going to simplify this first piece. I have the ln of x plus 4 over x minus 4. Still minus this ln of x squared minus 16. So you know what we're going to do next? We're going to divide those two. Now, You can divide it however you want. What I would do is maybe just put a division symbol here, just so I don't lose too many people. I wouldn't stack it. And what do I remember? I remember, and some of you already have written it this way, that it looks like that, right? That you multiply by the reciprocal. I remember too that we need to simplify, as you will too. And then I would simplify by crossing out these guys right here, the plus 4s. And what are we left with? Ln of 1 over x minus 4 to the second power. That's what that guy looks like. Way more simple than that split apart thing, right? And sometimes that can help us. They do want you to be familiar with the change of base formula. So I'm just going to put, how do we use a calculator to find a log? That's not base 10 or base e. Now, why am I focused on those? Because both of those bases are on your calculator, and we're going to need those, right? And you can use either one in order to do this. So an example that they had was something like this: log base 5 of 35. Okay. If we want to do that, this will always equal what we call the change of base formula. And so we don't have a log base 5 button on our calculator. There's no log with the base x that you can then plug in a 5, because what we can do is relatively quick and be less entry and finding buttons. You take log of the number over log of 5. Now I chose log because log's on my calculator. It would be the 100% the same ratio if you look at it like that. No matter which log function you choose, you're going to be able to get the same answer. So if I look at the log, let me find my log button, log of 35 divided by log of 5, I'm getting an answer that makes sense, 2.209. So I'm just going to put 2.2 if you're okay with that. Now if I did ln, let me try ln, which is on my thing, of 35 divided by ln 5. I get the same answer, exact same answer out to however many digits I want. It wouldn't matter which one you choose, right? So you just choose, you're choosing a function that's on your calculator because the other one's not. And you come up with 2.0. Now, does 2.2 make sense? Absolutely it does, because what's 5 squared? 25. What's 5 to the third? 125. 35 is really close to 25, so 2.2 makes sense. The answer had to be between 2 and 3. And so it will make a whole lot of sense there. Those are the styles of questions that we're having to deal with in this. So there are some other questions that are along the way. Let me see what number I'm up to. Number 5. I saw this one in there and didn't want it to take you by surprise. ln y is equal to 13 plus ln c. And what they would like you to do is to find y, right? And not just, so maybe find y is too hard, or not the right way to say it, I guess. Express y as a function of x would be a better way for me to say what they're asking us to do. Apologize for not saying it that way the first time. No problem. If you're going to do that, then what you need to do is, if you have logs involved and you need to peel them off, which we do because of this y here, you want to bring all your logs together. So the first thing I'm going to do is I'm going to bring my ln c over here. Then you're going to use property of logs to combine them. So this is ln y over c. And that's equal to 13. Okay. Okay, now I made a mistake in my translation. There's no x, so let me get an x there. I'm like looking at it, I'm like, there's no variable x, it's just a number. So there, now we're better. So there was an x there from the beginning that I didn't mean to leave out. So everybody okay with where we're at? That's what I'd ask you if you were in a class. But hopefully you're okay. So the first thing you do, just like with anything, if you had a square root equation, you'd isolate the square roots on one side. If in this case, if we have an ln equation, you get all your ln's together, combine them, and then you're just using the definition of logs. The base, hopefully you see the base is e to the power, is equal to what log's operating on. And you can see very easily how to solve for y. You're just going to multiply both sides by c. And that's how you're going to get your y. If we look at one more example like that just to practice, remember what the procedure is. So again, we want to solve for y and express it as a function of x. Essentially, this is the last part in what we call logarithmic differentiation. You use logs to split things apart so that you can handle them easier, and then you have to put them all back together. And so this will be something that you do in your class. So what are we going to do? Remember, step one, bring your logs on one side of the equation if you have more than one. Now we don't want to deal with split apart logs, so we're going to again bring those together. This is y minus 2 over c is equal to negative 7x. And then we're just going to translate the exponential. E to the power is equal to what log's operating on. And then we're just going to solve for y, much like we did when those sections that we had where we solved for a variable. So in our intermediate and beginning algebra classes. So we're going to multiply both sides by c. Let me put that here in a different color. Multiply both sides by c. And then, so what are we left with? Or what do we obtain? C e to the minus 7x is equal to y minus 2. And then we're going to simply add over the 2. And now you know what y is. I'll keep y on the same side that it is so it doesn't look too crazy. This is c e to the minus 7x plus 2. And that's what we have. That's what y would be equal to under that situation. So it's totally doable. Gets us to play around with logs. You can see even these last ones are using properties of logs. They're just trying to get you some experience there in the different situations that are really, really application based for the future. So that's the good part about it. Let me know again if you have any questions or concerns.